So, dear students, I welcome you in the lecture series of Chemical Equipment Design. Today we are going to discuss related to the agitator shaft key. In the last class, we have discussed related to the shaft, how it is to be designed. What are the different considerations for shaft design that we have talked. Today we are going to discuss related to the shaft key. Now, basically, when you talk a key, so the most common function of the key is to prevent the relative motion of a shaft and the hub. Now, look at this figure. The shaft is provided, and on this shaft, there is a hub that is provided. And to this hub, you are attaching the impellers, the different types of the impellers that can be attached to this hub. So the relative motion, your shaft that is rotating, and this shaft is transmitting power to the hub and ultimately to the blades. This is most important thing. Shaft that is rotating, it is rotating because of the motor, and this shaft that is rotating, and because of this rotary action of the shaft, it is going to transfer it to the impellers. But impellers, they are attached to the key. Impellers that is attached to the hub. Now, how to fit a shaft and a hub? There we are using a key. So keys are generally the square keys or the rectangular keys they are used, so that a groove that is made into the hub and the groove that is made into the shaft. So there is a groove in the shaft as well as the groove in the hub, and in between these two grooves the key that is fixed, which provides the relative motion. So the most common function of the key is to prevent the relative motion of a shaft and the hub. The key is subjected to crushing and shearing load and therefore made of the steel. In order to set the key in proper position, the groove called the key seat is cut into the shaft, and the groove called the key way is cut into the hub. Now looking at this figure, the shaft, the groove that is provided, this is called a key seat. A key seat is provided in the shaft, and a key way is provided into the hub. Now, while if the question that is asked, you should be able to draw the figure also. So we will try to draw a rough figure with this. The figures are essential part. So you can conveniently or similarly draw the shaft and the hub assembly. This is with annotating, so the figure is not that good, but I hope you have got the idea how to draw the shaft and the hub. So there is a keyway and a key seat. In general, your keys, they are rectangular or square in shape. So it is having the key is having the two areas that of concern. One is the complete area, this is the width, and the length, this is the area in shear, and width or thickness divided by the 2 into the L, thickness divided by 2 into the L, that is the area in crushing, area in crushing. So these two areas are of importance. Now, while designing a key, we must understand from where this power that is coming in, which force is exerted on the key, and by which different ways the key can break. So, whatever the applied power that is there, applied power from the motor is transmitted to the gearbox, right? And then this gearbox is connected to a shaft which is getting rotated. So this applied power from the motor is transmitted to the gearbox and then to the shaft. And this shaft power will exert the force on the key. Now when we talk a shaft power, this is nothing but a torque that is provided. This is what we have discussed in the last class. That is, the motor is provided with a certain twisting, or the torque that is provided. That is a torque that is provided, twisting that has been provided to the shaft. So this is nothing but a torque which is exerted. And yesterday we have talked its formula, that is the Fs into the 16d upon pi d cube upon 16 into the Fs. This is the torque which we have talked in the last class. Now the key, how it will fail? The key will fail by two different ways. That is, one is by crushing and another is by shearing. So a square key or a rectangular key is more common. The key has to be strong enough to avoid the failure. So this is the most important thing that is to be understood. And let T is the torque, the same terminology, the torque to be transmitted by the shaft. This torque that is transmitted by the shaft, and force at the shaft force can be calculated as this force P, which is equal to T into D by 2. We know that torque upon the sectional modulus, which is nothing but equals to the stress F, and this stress that is also equals to the force per unit area. So this is the important consideration that is required for this. This is torque upon sectional modulus, which is nothing but the stress, and stress is also equals to the force per unit area. These formulas are required here. Now this is the P, that is the force at the shaft circumference. So this is nothing but a torque. Now I have applied a certain force to this shaft, force that is applied to this shaft. What it will produce? It will produce a twisting moment. It will produce a twist. It will produce a torque. and that is why this applied force to the hand ऊपर that is hanging only. I am putting a certain force shaft के ऊपर दे रहा हूं मैं, तो torque that will be generated and the sectional modulus is d upon 2. So the applied force P, which is equal to the T upon d by 2. Now this is to the shaft. Now this shaft force will be applying a force on the key. Now consider that this is the key, a rectangular key that is provided. One face is there, second face and a third face. Three faces are there. Now out of this I am putting a shaft key like this, right? Shaft key like this in between the hub and in between the shaft. So a certain force that will be exerted, this will be the shearing force, and this will be the crushing force. This will be the crushing force. Area that will be related to the crushing. Now when we talk to the shearing, so shearing force will be the complete force because it can get twisted like this. It can get twisted like this. तो ये area जो है इसके ऊपर suffer होगा because I am putting the force like this. ऐसे twist करूंगा मैं इसको तो it will be this area that is affected. So this applied force P will be associated with the area WL into the stress. The same formula, stress which is equal to the force per unit area. This is what force is the P and WL is the area and Fs is the stress. So I can write this or equate this load which is equal to the 2T upon D from this and calculate the value of Fs which will be 2T upon WLD, right? Similarly, the strength of key for failure in crushing. So this is the area P which is equal to L into T by 2. This is nothing but the affected area. Now why T by 2 that is taken? Now half of the part or half of the section is there in the hub and half of the section there is in the shaft. Half section is in the shaft and half section is in the hub. That is why T by 2 that has been taken into account because this is by crushing and the applied force of the crushing is provided through the shaft. तो shaft का force जो apply हो रहा है वो half of the area पे half of this area that will be considered. That is what the length into thickness by 2. So this is the power which is equal to L into T by 2 into the stress. Now here it's a crushing stress. Above it's a shear stress because we are twisting, so it becomes a shear stress. We are compressing or crushing, so it becomes your crushing stress. So stress which is equal to nothing but force per unit area, and that is why the P which is equal to L into T by 2 into the Fc, which is also equated to the 2T into upon the D, and this Fc crushing stress that is will be equal to the 4T dl upon T. So this is what the applied force from the or the applied torque from the shaft is transmitted to the key, and key can fail by shearing action or by crushing action. सो दिस टू थिंग्स आर इंपॉर्टेंट. फोर्स मैं शाफ्ट को अप्लाई कर रहा हूं तो वो की कैसे ब्रेक होगी, ये दो चीजें ही इंपॉर्टेंट है, आइदर बाय क्रशिंग और बाय शेयरिंग. नाउ I can equate these forces. The force in the shearing and the force in the crushing. So above equations, the force P in shearing and force P in crushing is same. So by equating the two strengths, WL into the Fs, which is equal to the L into TC into the FC. इथूनच torque that is equated. Torque में force that is equated. P, which is nothing but L into T by 2 Fc. This is T by 2. This is not T by S. This is T by 2. And which is nothing but WL into the Fs. So this WL into the Fs, this is equated to the L into T by 2 into Fc. You will simplify it to the 2W T into the Fc upon Fs. So after simplification, you will get the ratio of the width to the thickness. Width to the thickness. So this is what the width and the thickness of a key. इसका ratio जो है that you got. Now a square key with the sides D by 4 is preferred. In general case, a square key with a side D by 4 should be preferred. So what it means, D is nothing but a shaft diameter. Shaft diameter has made a groove of 75% of 25%. जो भी shaft diameter है उसका 25% groove that has been made. So it becomes your D by 4. Now the allowable crushing stress is twice the shearing stress. Now where it will come? When W that is equal to the D by 4. So if the key is perfectly fixed in the shaft and the hub, if the key does not fit perfectly in the shaft and hub, then the crushing stress is about 1.7 times the allowable shear stress. This allowable crushing stress is twice the shearing stress when it's a square key. When it is a square key. Square key means W which is equal to the T. W which is equal to the T. So this will get cancelled and Fc will be is equal to the 2 times the Fs. Fc will be equals to 2 times Fs. That is what the allowable crushing stress is twice the shearing stress. Fc which is equal to 2 times Fs when it's a square key. Square key width and the thickness they are equal. That is what W which is equal to the T. This is for a square key. So the length of a key is determined by equating the strength. Now this is what we have talked is the width. And what is the width? That is D by 4. Now what should be its length? That we will talk. So the length of a key is determined by equating the strength of key in shear to the strength of the shaft in shear. So the two things are required for the key and for the shaft in shear. So Fs is your shear stress. Already we have calculated here the Fs, which is 2T upon WLD. So I can calculate T from here, which is equal to the Fs WLD upon 2. This is the same thing. T, which is nothing but WLFSD upon 2. This is T torque, which is equal to the strength of the key in shear. Strength of the key in shear, right? And this is the strength of the shaft in shear. Strength of the shaft in shear. They are equated. This formula we have talked in the last class, that is related to the shaft torque. Torque, which is equal to pi d cube upon 16 into the Fs. Now substitute the value W, which is equal to the d by 4 in the above equations, simplify it, and you will get pi by 2. Pi by 2 is 3.14 divided by 2, which is approximately equal to the 1.5. So length should be equal to the 1.5 times the shaft diameter. Then if the rectangular key is weaker in compression than in shear, it is assumed that by cutting the key way, the torsional strength of shaft is reduced by 25%. Why 25%? Because we have made a groove or the key seat. This key seat is nothing but a groove that is made into the shaft, and because of this key seat groove, the strength of the shaft that is reduced. In general case, this groove is 25% of the shaft diameter. This groove is 25% of the shaft diameter. So what will be the remaining strength? Is the 75% is the remaining strength of a shaft. And that is why we are calling it, it is assumed that by cutting the keyway, the torsional strength of the shaft is reduced by 25%, because we are making a groove of 25% in the shaft. So that is reduced by 25%. So what will be the strength that will be remaining? Is the 75%. So this is what the strength in the shaft, which is Fs into 0.75. This is what is the remaining. The torque T, which is nothing but the strength of the key is this thing, and strength of the shaft is this thing, but it is reduced to the 75% because we have already cut it 25%. So substituting W, which is equal to d by 4, it comes as 1.2 times the d, or already we have talked 1.5 times the d. There we have not taken into account the reduced strength of the shaft. When the shaft strength that is reduced by 75%, the length of the key that is also reduced by the 75%. That is 1.5 divided by 0.75, which comes as 1.2. So this is related to the failures in the key. Now causes of shaft failure. the presence of cyclic overload due to the incorrect estimation by the designer. Then stress concentration is one factor due to the production or operation causes such as undercuts, machining, and the traces and other points of stress concentration. In many causes, the failure begins to develop at a point of maximum stress concentration or the keyways, drilled holes और fillets जो weaker sections है वहां पे failure हो रहा है in general case. Then next is a faulty installation. That is another reason. When you talk related to the warranty of your fan, there this if the fan is faultily installed, then the warranty voids there. So wrong bearing adjustment, insufficient clearances, that can be also the reasons for shaft failure. Shaft get damaged due to the seizure, scoring, and melting of the lining of the sliding bearing. Then inadequate bending stresses can cause the excessive flexure. Then excessive torsional deflection, that is one of the reasons. Then excessive transverse or torsional vibration, that is what the overhanging, इसके कारण overhanging हो रहा है. This is what the torsional deflection that is taking place. Golgon फिरताना sometimes you can see that it is rotating like this. Fan is rotating like this. It is one of the reasons for failure. So these are the different reasons for shaft failure. Now we will consider a numerical based on this. Okay, now this problem, in a certain mixing operation, a shaft 50 millimeter in diameter transmits a torque of 12,000 kg centimeter. A square key is used whose one side is equal to the 1/4, means square key that has been mentioned, whose one side is equal to the 1/4 of the shaft diameter, that is W by D, and whose length is equal to 1.5 times the shaft diameter. Determine the dimensions of the key and check the key for its induced shearing and crushing stress. Also determine the factor of safety of the key in shear and crushing when yield stress in shearing and crushing are 3500 kgs per centimeter square and 4250 kgs per centimeter square respectively. Now this is given as a mixing operation, a shaft diameter that is 50 millimeter. So what will be the width of the key and what will be the key length? That is W, which is equal to the D by 4. So 50 by 4, that comes out the 12.5 mm, and the length of the key is 1.5 times the diameter, shaft diameter. So that comes out to the 75 mm. As it is a square key, so the width that will be 12.5 mm. This is what the mentioned data we have analyzed it or converted it. Then the force for shearing and crushing of key. The force P that is applied because of the shaft 2T upon D. So this is 2 and torque that is given as 12,000. D is diameter in centimeters, 12,000 kg centimeter is the mentioned torque. So 4,800 kgf. So shear stress induced in the key. This is from the shaft. This is torque developed by the shaft. Now this torque that is transmitted to the key. So the shear stresses in the key, that is 2T dWL. So 2 into 12,000 upon 5 into the thickness width 12.5 centimeter 12.5 mm, that is nothing but 1.25 centimeter, and similarly 75 mm length of the key 75 mm hai, so it becomes 7.5 centimeter. So it comes as the 510 kgs per centimeter square. Similarly, crushing stress induced in the key, that is FC, is the crushing stress, which is nothing but the 4T dl into the T, which is nothing but 4 into 12,000 upon 5 into 7.5 into 1.25, which comes out as the 1020 kgs per centimeter square. So from the torque of the shaft, you have considered the shearing stress and the crushing stress. तो क्रशिंग स्ट्रेस और शेयरिंग स्ट्रेस कैलकुलेट हो चुकी है. On the same side, you have mentioned in the problem that is also determine the factor of safety of the key in shear and crushing when the yield stress in shearing and crushing is given respectively. Shearing, it is 3,500 kgs per centimeter square, and for crushing it is 4,250 kgs per centimeter square. So it has to be compared. This is actually from the torque we have calculated, right? Shearing and crushing stresses from the torque we have calculated, but the defined mention is that of a material. So factor of safety in shear, that is for the actual material which is provided, and up to maximum this can be used. So the factor of safety of 6.86 that is coming into the picture, and factor of safety in the crushing that is coming out as the 4.17. So this is related to the calculation of the stresses in the key and the consideration of the factor of safety.